Okay, we're going to look at a geometric series. We've looked at arithmetic series, arithmetic sequence, and geometric sequence. A geometric series is basically a geometric sequence where you're adding the terms together. Here's an example of a geometric series. You're multiplying by 3 each time, and you're adding the terms together. To find the sum of a geometric series, we actually have 3 different formulas to choose from. However, most of the time you will use either this first boxed-in formula or the second boxed-in formula, where the a sub 1, no matter which formula you're dealing with, is your first term. A sub n shows up here in this last term, and that's your last term over here. R is still your ratio, and you can only find your ratio or find your sum if R is not 1. These formulas do not work when R is 1. But if R is not 1, you can use these formulas. So let's go ahead and find how many direct ancestors a person would have after 8 generations. Well, let's start by listing out our generations. You each have a biological mother and father, and then they each have biological mothers and fathers, so you'd have a total of 4 biological grandparents. And then you go back another generation, you get 8, another generation, you get 16, and so on. And we're trying to figure out how many you're going to have. Well, this is our geometric series that we need to find a sum of. It's a series because you're adding. It's geometric because you're multiplying by 2 each time. We could use this top formula if we wanted, because we know our first term, that's the a sub n. We know r is 2 because you're multiplying by 2 each time, and n is the number of terms you're dealing with. So you have 1, 2, 3, 4, 5, 6, 7, 8 terms. You can see that listed, or you could use the idea of 8 generations. So when you plug that stuff in, a sub 1 is 2. Your ratio right here is also 2. 8 is your n, and then plug in r in the bottom for your ratio. Then you'd want to type this into your calculator, put the whole top in parentheses, hit divide, put the whole bottom in parentheses, and you get 510. You'd want to do the same type of thing here. Let's go ahead and see what we have here. We know this is given to us in summation notation. The number down here tells you what number to put into your rule first to get your first term. So you plug in a 1. Exponent then becomes 1 minus 1 or 0. 2 to the 0 is 1 times your 3 is 3. So your sum, or sigma here means sum, so you're going to go 3 and then add something. You put in 1, so now let's try the next number up of 2. Plug in 2, exponent becomes 2 minus 1 or 1. 2 to the first is 2 times your 3 is 6. Now you want to go ahead and try the next number up, say 3. Plug in 3, you get an exponent of 2. 2 squared is 4 times 3 is 12. And then you want to keep doing that. And I'm not going to list them all, so I'm going to just go dot, dot, dot. You don't need to list them all. And then let's go ahead and plug in our last term. Our last term is what you get when you plug in the top number. Take 12, plug it in, it'll be 12 minus 1 of an 11. 2 to the 11th times it by 3. And we will get this term here. Now, I'm going to go ahead and use this formula here. Since I have my first term of an a sub 1, my last term is the a sub n, and I know my ratio. I'm multiplying by 2 each time. So I'll plug in my first term, plug in my last term, multiply it by my ratio. Notice I have no exponents here because I'm using that other boxed-in formula from the previous slide, over 2 minus my ratio. Put the whole top in parentheses, put the whole bottom in parentheses with a division sign in between on your calculator, and you would get this. Now, you could have used that other formula. If you had used this formula here, you would have put in your first term for the a sub 1s, which is a 3, You're multiplying by 2 each time, so your ratio is 2. We had a total of 12 terms. Remember, when the summation notation, to be able to figure out how many terms, you take the top number minus the bottom number and then add 1. And so that's what our n is. And so whichever one you use, you're going to get the same answer. Here, you're asked to find your first term. But you know the sum of the first 8 terms is this, and you know r. Well, the sum of the first 8 terms, your subscript is 8, so that means n is 8. So which formula deals with your s, your n, your r, and your first term? Well, to do that, that would be this one here. So we're going to go ahead, plug in this information. Okay, we'll try that again. What I had up there before was totally messed up. Sorry about that. I'm going to go ahead and, in just a second, I'm going to use this formula here. Now, we're trying to find a sub 1, which happens to be your first term. I like this formula versus the first one here because a sub 1 shows up in 2 spots. If a sub 1 shows up in 1 spot, it's going to be easier to work with. I know my s sub n, that's at 765. Don't know my first term. Then go 1 minus my ratio, which is 2, and I know my n is 8, all over the 1 minus 2. So now we want to work this out, our 765, work out the top, get negative 255, work out the bottom, negative 1. Negative divided by negative is a positive. Then to get rid of the multiplying by 255, you want to divide by 3. And see, we have it again here. Sorry about that.